Okay, so this is the third question for the Physics 102 final, where we have again this arrangement where a bar is sliding on frictionless rails. The first part asks us to find the direction of the induced current. Well, as the thing is falling down, flux, which is into the page, is increasing. I know Lenz's rule. Lenz's rule tells me that response is to oppose the change. So if this is increasing, it will tend to decrease it, which means created phi must be coming towards me. And what kind of current creates a magnetic field towards me? It's going to be a counterclockwise. So induced current is counterclockwise. That's part A. And if it's counterclockwise, it's flowing like this, which also makes sense because F, as you remember, is I dl cross B. dl is to the right, B is into the page, so the magnetic force is opposing the motion. So that makes sense. What's the terminal velocity of the wire? Terminal velocity means that this guy is actually moving at constant velocity, which means what are the forces on it? mg, and F magnetic. It means at terminal velocity, F magnetic must equal mg. F magnetic is B times I times L. How about I? Well, what's the induced EMF? It's B times V terminal times L divided by the total resistance. So let's just plug this in. B times L square V terminal divided by resistance must equal mg. So the terminal velocity must be mg r divided by VL square. How about part C? Find the rate at which energy is dissipated in the resistance. So the power dissipated on the resistance is I square times R. That's the power. Well, I already wrote down. So this is going to be PL VT over R square. But what's VT? I can now plug this in. BL. This is I square times R. BL over R times VT is mg R BL square. So that's nice. BL's cancelled. I have R's cancelling here. So this gives me mg times R divided by BL square. Where is this energy coming from? It's the work done by the gravitational potential. So power gravitational will be F times V. F is mg, V is V terminal. Oh, okay, so I have to be careful, right? Mg square, BL square. Good. Mg times R divided by BL square. So that gives me mg over BL square times resistance, which is the same. So we have correctly solved this problem.